In Proposition 27, the claim is that if a straight line following on two straight lines make the alternate angles equal to one another, the straight lines will be parallel to one another. So let's draw this out. So this is going to be our straight line EF following on the two straight lines AB. Let's say this is going to be AB, and this one's going to be CD. So we'll label these. So here's A, B, C, and D. Here's E over there and F over there. So the claim is that if the alternate angles AEF and EFD, if these alternate angles are equal to one another, then AB is parallel to CD. AB is going to be parallel to CD. That is to say, on neither of these two sides will these two lines meet. And we're going to prove this by supposing that they do meet on one of these two sides. For if not, AB and CD, when produced, will meet either in the direction of BD, either over here, or towards AC. We'll take the first case, let them be produced and meet in the direction of BD at G. So what he's saying is, let's say AB, when produced, let's say AB when produced, and when CD is produced, let's say they meet over here. We'll call this point G. Then we're going to think about the triangle GEF. So it's a weird looking diagram, but doesn't matter. Then in the triangle GEF, the exterior angle AEF, notice that AEF is an exterior angle in that triangle. That exterior angle is equal to the interior and opposite angle EFG. That was a given. These two angles are equal. But then if that's the case, then we have an exterior angle being equal to one of the opposite and interior angles of the triangle. And that's impossible. We've proved that's impossible by Proposition 16. So this whole situation is absurd. Therefore, AB and CD, when produced, will not meet in the direction of BD. And a similar argument can be used to show that the two lines AB and CD cannot meet over here in the direction of AC. And he doesn't give the argument explicitly because it's very clear how that's going to work. Let's go through it briefly. So if AC meet over here, let's say they meet over here. Let's say there's some weird point over here called H. Let's think about the triangle HEF. So if they do meet, that implies that we have this exterior angle EFD being equal to one of the opposite and interior angles of the triangle, namely HEF, which is this one over here. But that contradicts proposition number 16, just like the other part of the proof. Therefore, it's also impossible that the lines AB and CD, given the equality of these two angles, that they could meet over here at some point H. So they can't meet in either of the two directions. And by definition 13, that's just what it means for two lines to be parallel. Therefore, AB is parallel to CD. Now, since this proposition is about parallel lines, you might be tempted to think that this has some sort of relationship to the fifth postulate, sometimes called the parallel postulate. But take careful note that the fifth postulate was never used during this proposition. The proof never employed the parallel postulate. So the negation of the parallel postulate has nothing to do with this proposition.